everyone. Yeah, this is Abhishek KV. Welcome to my YouTube channel. I hope you are all studying well. Yes, last class we completed the third chapter, matrices, right? I already told you to learn the fourth chapter, that is determinant. Matrices is the basic tool, right? So in this session I am going to start the next chapter, that is chapter 4, determinants. In order to define the determinant, first I am going to consider the system of linear equations. See, if I consider a1x plus b1y is equal to c1, then a2x plus b2y is equal to c2, then I write this system of linear equation as b1 a2 b2. See, this is what the matrix of order 2 cross 2. You all know matrix is a ordered rectangular array of numbers or functions, and then multiplied with x and y. This is equal to c1 and c2. So this is of the form ax is equal to C. That is, A is the matrix of order 2 cross 2. This matrix contains the coefficient of x and y. See, coefficient of x and y, a1, b1, a2, b2, and this x represents the variables in the system of linear equation. This is equal to c1 and c2. This has order 2 cross 1. This also has order 2 cross 1. Therefore, Ax is equal to C. I write this system of linear equation as Ax is equal to C, where A is the coefficient of x and y, x is the matrix containing the variable xy, and C is the constant representing the system of linear equations. See, now the question arises whether this system of linear equation has uniqueness or not. How can we determine this? By consist this system of linear equation, this system of linear equation has uniqueness or not. Its uniqueness or not is determined by the number a1 b2 minus a2 b1. Then the question arises, how this number comes? Recall that if a1 by a2 is not equal to b1 by b2, or a1 b2 minus b1 a2. How it comes? See, by cross multiplying this is what? Not equal to 0, right? Cross multiply this a1 b2 minus a2 b1. This is not equal to 0. Then the system of linear equation. Then the system of linear equation. Then the system of linear equation has unique solution. Therefore, this number is called determinant. This number is called determinant of matrix. Determinant of matrix. Which matrix? A1, B1, C1, A2, B2 of order 2 cross 2. A1, B1, A2, B2. This is the matrix 2 cross 2. Therefore, A1, B2 minus A2, B1 is the determinant of the matrix. This is the determinant associated with the matrix A1, B1, A2, B2. So this is the value of the determinant for 2 cross 2 matrices. Then the question arises, sir, what about the matrix 1 cross 1? What about the matrix 3 cross 3? What about the matrix 2 cross 1, or except 2 cross 2, what about the determinant? Let us discuss about that. Let us discuss about that. And here we should note that. So this is about the introduction of determinant, and in this chapter we are going to learn the determinant of the matrix, determinant of the matrix up to order 3 by 3. And you should note that if matrix A is equal to A1, B1, A2, B2, then determinant of A is determined by taking the diagonal element, product of diagonal element, that is A1, B2 minus the product of anti-diagonal element, that is B1, A2. See, if A is the matrix, see this is the matrix 2 by 2, then determinant of A is determined by taking the product of diagonal element minus the product of anti-diagonal element. See, A1, B1, B2 is the diagonal element, A2, B1 is the anti-diagonal element. This is for 2 by 2 matrices, and here we should note that this is read as determinant of the matrix A, and but not the modulus, of A. Understood? This can be read as determinant of the matrix A, but not the modulus of A. And here we should note that determinant of the matrix, determinant is defined. Determinant should be defined. Determinant should be defined only for square matrices. Only for square matrices. Yes, determinant of the matrix up to order 3 cross 3. We are going to determine the given matrix up to only for 3 by 3. If, for example, if I consider the 2 by 2, A1, B1, A2, B2, then determinant of A is denoted by this symbol, and as the value A1, B2 minus B1, A2. This is for 2 by 2, and determinant of A is this can be read as determinant of A, but not the modulus of A. You should know that. And determinant should be defined only for square matrices. What is square matrices? A matrix is said to be a square matrix if it has equal number of rows and columns. That is, number of rows is equal to number of columns. See, if I consider this one A1, A2. If I consider A is equal to this, what is the determinant of A? This does not exist. Determinant of A does not exist. Why? This has the order 2 by 1. Determinant can be defined only for square matrices. Here, this is the note. Understood? So, I already told you, this is for 2 cross 2 matrices. Generally, how can we define determinant? Generally, how can we define determinant? So, here is the definition. To every square matrix, say A is equal to Aij. To every square matrix A is equal to Aij of order n. Square matrix, see, I already told you, determinant can be defined only for square matrices. Say A is equal to Aij. Aij is the suffix of this number. See, A11, first row, first element. Ith row, ith column. First row, first column, right? So, of order n, we can associate a number. This can be real or complex. The number can be real or complex, but in our syllabus we are going to learn the determinant determinant up to order 3 with real entries only. So not applicable with this determinant is not applicable for complex for your syllabus. Okay? It can be associated with a number. This may be real or complex, and this is called associated number is called determinant of determinant of the square matrix. Determinant of the square matrix. See, this is the definition. To every square matrix, A is equal to Aij. Here, where Aij is called I throw jth column element. Jth column element of the given matrices. Of the given matrix of order. We can associate a number. It may be real or complex, but in your syllabus we are going to learn this determinant for only real values, and especially we are going to learn up to 3 cross 3 only. Up to 3 cross 3 means we are going to learn 1 cross 1, 2 cross 2 and 3 cross 3. Okay, we are going to learn only for these orders. That is number of rows, number of columns, number of rows, number of columns, number of rows, number of columns. Is it clear? So this is the definition. Okay. Then I move on to determinant of order 1. See, I move on to determinant of order 1. How can we define determinant of order 1? See, if I consider a matrix, say A is equal to A, this has 1 row, 1 column, right? Therefore, determinant of A is given by that number only. That is, if I consider a matrix A is equal to 2, what is the determinant of A? 2 only. Is it clear? This has the order 1 by 1. Rows, column. Number of rows is equal to number of columns. So this is the way to determine of order 1. Then, what is the procedure for determinant of order 2? What is the procedure for defining the determinant of order 2? I already told you. If I consider the matrix A is equal to Aij of order 2 cross 2, that is, see, Aij of order 2 cross 2 is of the form A11, A12, A21, A22. This can we already learned in matrices. See, first row, first column, first row, second column, second row, first column, second row, second column, first row, second row, first column, second column. This has the order 2 by 2. Then determinant of A is given by, I already told you, product of diagonal elements, that is A11, A22 minus the product of anti-diagonal elements, that is A21, A12. For example, if I consider this matrix A is equal to 2, 4, 6, 8. 2, 4, 6, 8. This is the matrix of order 2 plus 2. What is the determinant of this matrix? See, determinant of this matrix is given by 2, 4, 6, 8. Determinant of the matrix is represented like this. This is the matrix, rectangular array of numbers. When I come to determinant, you should denote like this. See, 2 bars, and this is not absolute value. This is read by determinant of the matrix A, and it is given by what? Product of diagonal element. 2 8s are 60 minus 6 4s are 24. This is equal to what? 16 minus 24 minus 8. And don't be confused with, if I consider this, then this is wrong. See, determinant can be defined by taking the product of diagonal elements minus the product of anti-diagonal elements. This is for 2 cross 2. This is the procedure to determine the determinant value of the matrix 2 cross 2. Is it clear? So this has the value what? This is equal to minus 8. Is it clear? See, this is a square matrix. This is also a square matrix. We are remaining to learn the procedure for 3 cross 3 matrices, right? So let us move on to that. Determinant of order 3. Determinant of order 3. Determinant of order 3. How it is of the form? Let us consider the matrix A is equal to Aij of order 3 cross 3. We already know it is of the form what? first row, second row, third row, first column, second column, third column. That is A11, first row, first column. A12, first row, second column. A13, first row, third column. A21, second row, first column. A22, second row, second column. A23, second row, third column. It is possible to write A14? No. Why? First row, fourth column. We are needed with what? Only 3 cross 3. So we should stop here. Okay? Then third row, first column. See, first row, second row, third row. Still it is in first column. Still it is in second. Still it is in three, third column. But first row, 1, second row, 2, third row, 3. I hope you are all getting this. Okay? Then, so this is the 3 cross 3 matrices. 3 by 3 matrix. How can we define the determinant? See, the determinant can be determined by 6 ways. The determinant of order 3 by 3 can be determined by 6 ways. So what are those 6 ways? By expanding R1, R2, R3, C1, C2, C3. See, this means this can be determined. This value of the determinant of order 3 by 3 can be determined by 6 ways. By expanding R1. This means row 1, R2, row 2, R3, row 3. See, for all this expansion, you are going to do only one method, by R1 or by R2 or by R3, by C1 or by C2 by C3, by expanding R1, R2, R3, any one of these. But you will getting the same answer. Let us consider the procedure. See, if I am going to consider expansion along R1, see, this is R1, right? This is R1. First, we should consider the first element, that is this row, first element, that is first row, first column. Consider this. Then this can be multiplied with minus 1 to the power of 1 plus 1. Where it comes, this is the sum of suffix A11. Understood? Sum of the suffix A11. See, what is the suffix of this element? 1. This is the suffix, right? Sum of this suffix minus 1 to the power of, sum of the suffix is 1 plus 1. What is 1 plus 1? A11 into minus 1 to the power of 2. What is minus 1 to the power of even number? This is equal to minus 1 to the power square is equal to plus 1. So next step, A11 into 1. Is it clear? Then sum of the suffix A11. Then you should delete this first row or consider this first row, first column. That is deleting this column and deleting this row. Why? See, this element as A11, that is suffix 11. First suffix represent row, second suffix represent column. So you should delete the respective row and column which contains the suffix. That is first row get cancelled, second row get cancelled. You are remaining with what? Determinant of this row, this column get cancelled. You are remaining with what? A22, A23, A32, A33. Is it clear? Is it clear? See, by considering, if I am going to consider the expansion along R1, first we should consider the first element, that is A11. This represents what? First row, first column element, and we should multiply this by minus 1 to the power of 1 plus 1. This 1 plus 1 represents what? Suffix of the corresponding element into it reduces to what? 2 cross 2 cross 2 determinant, right? By deleting this first row, this first column, we are remaining with this. Clear? Then plus. What is the next element in R1? A12 minus 1 to the power of sum of this suffix, that is 1 plus 2. 1 plus 2. This is equal to what? A11 minus 1 whole square is plus 1. Then determinant of this, I already told you, determinant of 2 cross 2 is by taking the product of diagonal elements minus the product of anti-diagonal elements, that is A22 minus A33, A22, sorry, A22 into A33 minus A32 into A23, then plus A12 minus 1 to the power of 1 plus 2 minus 1 to the power of 3, it is minus 1, plus into minus, it is minus, that's all. Then next step is by deleting this first row and second column. First row, second column. First row, second column. We are remaining with what now? We are remaining with this row, this column get cancelled. We are remaining with the determinant. See, A21, A23, A31, A33. A21, A23, A31, A33. A33, is it clear? Then see, minus A12, what is the value of this determinant? See, by taking the product of diagonal elements minus the product of anti-diagonal elements, that is A21, A33 minus A23, A31, A31, then the last element, see, plus A13 into last element in R1 minus 1 to the power of 1 plus 3, addition of this suffix. Minus 1 to the power of 1 plus 3 means 4. Minus 1 to the power of 4 is plus 1. Minus 1 to the power of even number is plus 1. See, plus A13. Remaining with, see, by deleting now. By deleting first row, still it is in first row. And third column, first row, third column, we are remaining with this numbers, that is determinant of A21, A22, A31, A32, that is by taking the product of diagonal elements minus the product of anti-diagonal element, that is A21, A32 minus A22, A31. Is it clear? So this is the procedure to determine the 3 cross 3 matrices. Okay, let us consider one example for this. Let us consider. Before going to consider example, first I am going to give some note. First I am going to give some note. Please note down. See, this is the first note. First note. For easier calculation, we should expand. We should expand the determinant. We should expand the determinant along. We should expand the determinant along that row or column which contains the maximum number of zeros. Which contains the maximum number of zeros. Maximum number of zeros. We should, for easier calculation, we should expand the determinant along that row or column. Which row contains the maximum number of zeros? We should observe that first. I will come to that later. So take the second note. While expanding, instead of multiplying minus 1 to the power of I plus j, that is, if I consider I throw j column, that should be added. Minus 1 to the power of I plus j. We can multiply by plus 1 or minus 1. Plus 1 or minus 1 according to I plus j is even or odd. Even or odd. See, if I consider A11, A12, A21, A22. See, A11 into first row, first column get cancelled. We are and minus 1 to the power of 1 plus 1, right? See, I plus j is 1 plus 1. 1 plus 1 is even. If it is even, then it is plus. We are remaining with what? A22 plus. Then A12 suffix add this minus 1 to the power of 1 plus 2. 1 plus 2 is odd. If it is odd, then it is minus 1, that is plus into minus. This row, this column get cancelled. We are remaining with A21. Simply, we can write product of diagonal elements minus product of anti-diagonal elements. I hope you are all getting well. Is it clear? See, these are the two important points. Let us consider one example. If I consider this determinant, determine 1, 2, 4, minus 1, 3, 0, 4, 1, 0. Examiner like to ask this type of questions for 1 mark. Evaluate 1, 2, 4, minus 1, 3, 0, 4, 1, 0. See, I already told you determinant of A is determined by delta. Delta is equal to, see, if I am going to expand along R1, it has 1, 2, 4. If I am going to consider along R2, minus 1, 3, 0, again I am getting the same answer. If I am going to expand along R3, 4, 1, 0. Here it has 1, 0, here it has again 1, 0. But if I consider C1, no zeros, C2, no zeros. If I am going to expand along C3, how many zeros it has? 2 zeros. I already told you. This is the important one. For easier calculation, we should expand the determinant along that row or column which contains the maximum number of rows. Row or column. C3 contains maximum number of columns. So we should go through C3. See, this is C3 means this element. This element is A13. Suffix is 1, 3. Adding that 1 plus 3. 1 plus 3. I plus j means I is 1, j is 3. 1 plus 3 is even. If it is even, then it is plus 1. If it is even, then it is plus 1. Therefore, plus 1 into, consider that number. And A13 means deleting first row, third column. We are remaining with minus 1, 3, 4, 1. And no need to consider plus 0, minus 0, anything. Why? Because 0 into anything 0, 0 into anything 0. That's why the first note says expanding the determinant along that row or column which contains the maximum number of zeros. Is it clear? Therefore, see, this is equal to 4 into 2 cross 2 matrix, product of diagonal element minus product of anti-diagonal element. This is equal to 4 into minus 30. This is equal to minus 52. This is for 1 mark. Or if you are going to 1, 2, 4, minus 1, 3, 0, 4, 1, 0. If you are going to expand along R1, again you will get in the same answer, but this is the easiest calculation. See, this is equal to 1 into plus 1 because A11. Deleting this row, this column. 3 into 0, 0. Minus 1 into 0, 0. See, this is the best way. After learning to determine how to determine the value of the determinant, so this is the way. Then minus 2 because A12 element plus minus plus minus plus minus plus minus plus correspondingly plus minus plus minus plus minus plus minus plus. That's all. Minus 2 into deleting this row, this column. You are remaining with minus 1 into 0, 0. Minus 4 into 0, 0. Then plus 4. Deleting this row, this column. Minus 1 into 1, minus 1. Minus 4 3s are 12. See? 0. Minus 0. Plus 4 into minus 30. This is also equal to what? Minus 52. Minus 52. If examiner give, find the value of x for x minus 1, x plus 1, x